All right, we're going to move on with just increasing or varying the difficulty of the exponential equations we dealt with yesterday. It might make sense, I think, before we do that one, just to do one that reiterates what we talked about yesterday. So let's actually do, like if I say I want 7 to the 2x to equal 51. Okay? Because I cannot make 7 and 51 the same base, we have to directly turn to the use of logarithms. Okay, so you're going to take the log of both sides. So take the log of the left-hand side. Okay, and basically what happens is all I do is I put the left-hand side in parentheses and put the word log in front of it. Put the right-hand side in parentheses and put the word log in front of it. And what that does is it effectively tells me I'm taking the log of 7 raised to 2x. That's going to be equal to the log of 51. I can do anything I want to an equation as long as I do it to both sides. So I can take the log of both sides. Okay? Now, what that's always going to do, every single time, it's going to present you in a situation where you've got an exponent in that, we call that the argument. Okay, so you got an exponent there, and that exponent can always do what then? We go put it out in front of the log. Good, so we go 2x, and it's going to be times the log now of just 7 equals then log of 51. Okay. At this point, we talked about the last question we did yesterday. We've got an option. Okay. What do you guys want to do over here? We got to get x by itself. What do you guys want to do first? Okay. So you're going to do the whole thing. You're going to divide everything here by 2 log of 7. And I think the best thing, I think that is the best thing to do, but to actually write it down, because I can then say, okay, as long as I'm doing division and I understand how cancellation works through division, we can say, okay, that 2 cancels with that 2. This log 7 cancels with that log 7. And what am I left with? What's the only thing that did not cancel? X. Okay? And on the right-hand side, nothing cancels. I'm just left with log of 51 divided by 2 log of 7. I believe yesterday we did something like this. We kind of talked about this where you could do this division in 2 steps. So if I had 2x log of 7 equals log of 51, we could divide it by log of 7. And then divide it by 2. If I do that, algebraically, the correct way of writing this algebraically would look like this. I would divide by 2. So then I need to divide this thing by 2. When I divide by 2, it's really divided by 2 over 1. So I've got a fraction divided by a fraction. Anybody remember how to take a fraction divided by a fraction? Nope. You're going to take this thing here. You take the bottom fraction, and you find its reciprocal, and you multiply it by the top fraction. So what's 1 times log 51? Log 51. What's 2 times log 7? 2 log 7. So does that prove to you that you can either, if you're trying to solve for x, you can divide by the 2 and then divide by the log 7, or you can divide by the log 7 and then divide by 2, or you can do it all at once. Okay, I just want to try to give you options. People always think, oh, I got to do it the way Mr. Fay does it, or I got to do it the way that whoever the instructor does it. You don't. What you do have to do is just abide by the rules of algebra. Okay, and the better you understand those rules, the more freedom then you have within each problem to do it as you see fit. Is that right? Remember doing that yesterday? Let's then change it and do this one. So we're going to do 13 to 2x plus 1 equals 5. Okay, we have to make sure that the exponential part is isolated, and it is. Okay, and all of them I'm going to give you so far will be. Okay, so we can start using the log property right away. So basically all I'm going to do is write the word log in front of the left-hand side. So log inside in front of 13 to 2x plus 1. And log on the right-hand side. Log 5. Now, that's my exponent, right? That 2x plus 1 is what's going to come out in front. Okay, and when my exponent, would you guys agree that that's a quantity? That's multiple things added together? When I bring that out in front, I'm going to put it in parentheses. And my hope is that we can see maybe why we put it in parentheses. Remember what the goal is here. The goal is to get x all by itself, right? Okay. So we've got options here now. Okay. We've got options. Does anybody have an idea of what they want to do in order to solve for x here? What do you want to do, or what do you want to try? Okay, so you're going to distribute. So when you're going to take this and multiply it by that, and then multiply by that. Okay. So that's going to give me. So when I do that, it works. It's fine because this is a number, right? So whatever this number is, let's think about this. And this is where I always try to use my technology. If I don't remember a rule, okay, because she's saying, is that right? Well, let's see if our technology will help us realize that. If I have, isn't log of 13 just that number right there? Does that make sense? So really what this is saying is 2x plus 1 times that number of 1.11. And that's equal to log of 5. In this situation, would you distribute that 1.11? That would be fair to do, right? So let's do it with the log instead of the 1.11. So if I distribute this, this is the only thing you got to pay attention to. I'm distributing the whole phrase. I'm not distributing just the 13. So that whole thing right there is getting multiplied by 2x. So it's going to look like 2x. So like 2x log 13 plus then 1 times log of 13 equals then log of 5. Okay. Now what would you do? Subtract log of 13? Because that's just a number, right? Okay, so I'm trying to isolate this x, so I'm going to get rid of all the numbers that are attached to that. Now, log of 13 and log of 5, they don't work well together. So the way I'm going to write that is I'm going to write it as 2x log of 13 equals then this log of 5 minus log of 13. I think the number one thing that's going to help you realize what your algebraic rules are, what steps are, is to remember that log 13, log 5, log anything is just a number. Okay? It's just a number that we don't know off the top of our head. I can't put that on a number line because I don't know where it exists. If I change it to a decimal and do the work with the decimal, maybe that can help me realize how I do it with the actual log in the equation. How am I going to get this x by itself now? Well, what is that? If I just look at that, what does that mean to me right there? That means multiplication, right? It means I'm taking 2 and x and multiplying them together. If I look at that, that's just an extension of that. Now multiplying log 3 or log 13 by it, right? Can I divide and think about what we did in the last problem? If I divide by 2, does that 2 go away? If I divide by log 13, does that log 13 go away? And what's the only thing that would fall out there? Be x, right? If I divide the left-hand side by 2 log 13, I better divide the right-hand side by it, right? And that would be an appropriate answer. But that's not the only answer, and we're going to talk about this in a moment. I almost say, I guess it's not, it is the only answer, but it's not the only format of that answer. If I type that into Desmos, we got log of 5 minus log of 13, all divided by 2 log of 13. Gives you that number right there. So I just want to see if I raise 13 to the 2 times that number, negative 0.18626321846 plus 1, does it give me 5? Does that make sense? I took in my calculator 13 to the 2x, but x is that, or 2x plus 1, and now x is just that number there, and it spits back 5 to me. So I do have the right value. Okay, this was okay. In your homework, there's a couple questions that are going to ask you to write it in logarithmic form or using logarithms. They want you to type it in this way. Okay? And then the next part of that question will say, type it in as a decimal, and then once you type it in that way. So once you, and what they're trying to get you to see is that this one here is an exact answer, this one's rounded, and you can see the impact of using a rounded value inside the equation. It doesn't give back exactly the right-hand side, it gives back a little bit more in this case. Okay. Today's is going to be a little bit different. So this one here, let's look at this real quick. Let's use our properties. What do we know? If I just look at this, if I have subtraction in 2 logarithms or between 2 logarithms, can I merge that? Subtraction turns into what instead? Division, right? So let's just take that blue stuff and rewrite that as log of 5 divided by log of 13. Is that okay? Then I'm going to divide that. So that would be what this blue thing turns into. And then this denominator would still be 2 log of 13. Is that all right? Okay. Well, that's over 1, right? So let's take this, find its reciprocal, and multiply it by the top. So let's see if I get log of 5 times 1, just log of 5. And on the bottom, I get 2 log of 13 times log of 13. Does that make sense? Okay. Now, let's see what happens here. Let's go and see if we get the same result. See if we get the same number right here. If I type in log 5 divided by 2, log 5 divided by 2 log 13 log 13. It doesn't know. I want multiplication there, and it doesn't know that that needs to be parenthesis there, and parenthesis there. What happened? Yeah. Yeah. Did I mess up, or then I was an idiot? Oh, thanks. Thanks. That hurts. When we turn this into division, I don't know why I did this. When we turn it into division, it's not division of the log 5 and log 13. It's division of the 5 and the 13. So it turns into that. Does that make sense? See the difference? So that's my fault. So then we'll divide that still by this 2 log 13. So the only thing that changes, get rid of this. So we multiply by this reciprocal with 1 over 2 log 13, which so then I'll have log of 5/13 divided by 2 log of 13. And if I type that in, log of 5/13 over 2 log 13, are those two numbers the same? Okay. Now the reason I show that to you is because on MathXL, when you answer it and you maybe get it wrong, but you're close, they might give you feedback, or you do a view an example or something like that, and they give you information, they give you instruction. In class, if we've done it like that top one, but in the instruction that they give you in the view an example, they do the one I've got highlighted there blue, you might get completely lost. Does that make sense? But I'm just trying to open your eyes to the fact that because of our properties of logarithms, you can transform your answers a little bit and still be acceptable answers. Okay, your neighbor might do that, you might do that, you guys might argue, well, we're completely different. Change them to decimals and you're both the same. Kind of like the 2/4 and 1/2 idea. Okay, just a simplification process. Okay, so I want to go back to this part here because you guys said that you wanted to distribute, which is fine. It works. Okay, I'm a fan of not doing that, and I think it will make sense to you why. If I go 13 to 2x plus 1, that was equal to 5. If I take the log of both sides, so log of this side, log of that side, I can bring the 2x plus 1 out front. And when this is a quantity, it's a sum or a difference, I always put that in parentheses just to remind myself that when I do that, this whole thing is being multiplied by log 13. Can I divide both sides by log 13 right now? If this is just a number, because that's what the quantity, that's why I put in parentheses, because it's just a quantity. If I know what x is, let's say x is 1, isn't that number then going to be 3 up front? So I could divide everything by 3 if I knew what x was. So let's just go ahead and separate these two things, because they're being multiplied together. I'm going to separate them this way. I'm going to get rid of this log 13. I'm going to cancel that in there. Come over here, divide by log 13. So now I get 2x plus 1 equals log of 5 over log of 13. Is that okay with everybody? Okay. Subtract 1 from both sides now. So subtract 1 from both sides. That's going to go away, right? Now what can I do? Can divide both sides by 2. Now it's a little bit messier looking, and we haven't talked about a couple properties here that we could use to make it look just like what we had previously, but that's a completely different looking answer. Okay? But when I type it in, I type it in to get a decimal approximation. we go log of 5 divided by log of 13 minus 1, and then that whole thing divided by 2, does it still give me negative 1.86? Okay? So I'm just trying to get at the idea that you're going to have, you can have multiple representations and still be fine. Okay? Questions on that? We'll stop there today.